Your brain is at war, not with enemies you can see, but with information. Every second, millions of signals crash into your nervous system. The brush of fabric against your skin, the pressure of the chair beneath you, the temperature of the air, the faint ache in your shoulder. And somewhere in that storm, a single signal might mean danger. Your brain has milliseconds to decide, is this safe? Is this meaningful? Or is this a threat? From the soft graze of silk to the searing burn of a hot stove, your nervous system performs a lightning-fast odyssey, transforming external chaos into sensation, awareness, and sometimes pain. Tonight, we journey into that invisible world, from your skin to the deepest folds of your brain. This is the story of how you feel. Before sensation becomes awareness, it begins at the surface. Your skin is not just a protective covering. It is the largest sensory organ in your body, a biological interface between you and the universe. Within its layers live microscopic sentinels, specialized sensory receptors, each tuned to detect a different kind of physical interaction. The frontline receptors meet the first responders. Merkel cells, slow-adapting receptors that detect fine detail and sustained pressure. They allow you to read Braille, feel texture, and distinguish edges. Pacinian corpuscles, fast-adapting, onion-shaped structures buried deep in the dermis. They respond to vibration and sudden pressure changes. Meissner's corpuscles, sensitive to light touch and motion across the skin. Ruffini endings detect skin stretch and sustained force. These aren't just passive sensors. They are biological translators. When your skin is deformed, compressed, stretched, vibrated, the cell membranes of these receptors physically change shape. That mechanical distortion opens ion channels in the membrane. Ions rush in, and in that instant, physical force becomes electricity. This transformation is called transduction. Mechanical energy is converted into an electrochemical signal, the language of the nervous system. If the stimulus is strong enough, the receptor generates a surge known as an action potential, a rapid spike of voltage that travels along nerve fibers. Think of it like a digital message. All or nothing. No half signals, no maybes. Once triggered, the signal races along sensory neurons at speeds up to 120 meters per second, faster than a Formula One car. But here's where it gets fascinating. Not all touch is the same. Your nervous system separates sensation into two major streams. One, discriminative touch. This system tells you what and where. Is it rough? Smooth? Sharp? Is it on your fingertip or your forearm? How intense is it? This pathway travels through the dorsal columns of the spinal cord toward the brainstem. 2. Affective touch. This is the emotional dimension, the warmth of a hug, the comfort of holding someone's hand, the soothing stroke across your arm. These slower nerve fibers project toward emotional centers of the brain. One system measures, the other feels. Together, they create your physical reality. Once generated, the signal enters the spinal cord, the great neural highway. If the sensation is harmless touch, it ascends upward toward the brainstem. But if the signal represents potential damage, extreme heat, sharp pressure, chemical irritation, it activates specialized receptors called nociceptors. These pain receptors trigger a different route. The signal crosses immediately to the opposite side of the spinal cord and travels upward via the spinothalamic tract. Why? Because pain demands priority. In fact, sometimes your body reacts before your brain even becomes aware. Touch a hot stove, and your hand pulls back instantly. That withdrawal reflex is coordinated at the spinal level, milliseconds before conscious thought. Your brain receives the memo after the action is already taken. Protection first, awareness second. All sensory roads lead to a deep brain structure called the thalamus. The thalamus is the brain's sorting hub. Every touch, every vibration, every pain signal passes through here. It asks, where should this go? Is this urgent? Is this emotional? Is this precise? From here, signals are distributed to different cortical regions. The discriminative touch pathway arrives at the somatosensory cortex, located in the parietal lobe. Here lies one of the most extraordinary features of your brain: a body map. Different areas of this cortex correspond to different body parts, but the size of each area isn't proportional to body size. It's proportional to sensitivity. Your lips? Massive representation. Your fingertips? Huge. Your back? Much smaller. This distorted map is known as the sensory homunculus. When signals arrive, this region decodes location intensity, texture duration. It reconstructs the physical world with astonishing precision. But pain doesn't stop there. Pain is not just a signal. It is an experience. After passing through the thalamus, pain signals also travel to the insular cortex, the anterior cingulate cortex, limbic structures involved in emotion. Here, sensation becomes suffering. This is why a paper cut can feel intensely irritating, why heartbreak can physically ache, why chronic pain persists even after tissue heals. Pain has two components: sensory discriminative. Where is it? How strong? Affective motivational. How unpleasant is it? Your brain combines both to create the full experience. In other words, pain is not in your skin. It is constructed in your brain. What happens when this system goes wrong? Sometimes nerves fire without injury. In conditions like neuropathy, damaged nerves send false alarms. Sometimes the brain amplifies signals. In chronic pain disorders, the nervous system becomes hypersensitive, like a smoke alarm that won't stop ringing. And sometimes the opposite occurs. Under extreme stress, the brain can suppress pain entirely. Soldiers injured in battle often report feeling no pain initially, because in life or death situations, survival overrides suffering. Your brain recalibrates reality based on context. Here's the most astonishing truth. You never directly feel the world. You feel your brain's interpretation of electrical impulses. When silk feels soft, it's not because softness exists in the fabric. It exists in neural patterns firing in your cortex. When a flame burns, it's not heat itself that hurts. It's nociceptors triggering electrical signals interpreted as danger. Your brain constructs texture, temperature, pleasure, agony. Every sensation you've ever felt, from a gentle touch to unbearable pain, has been an electrochemical symphony inside your skull. Right now, as you sit watching this, your skin is detecting pressure from gravity. Your clothes are brushing against you. The air temperature is shifting. Your muscles are stretching. Millions of signals are traveling from your body to your brain. And most of them, your brain is ignoring, because it has already decided they are safe. But if something changes, if danger appears, your neural battlefield activates instantly, in milliseconds, silently, relentlessly. Your brain is not just helping you feel the world, it is helping you survive it. And every touch you experience is proof that your nervous system is alive, vigilant, and constantly translating the chaos of reality into meaning. If you enjoyed this deep dive into the hidden world beneath your skin, subscribe to Inside the Human Body, where we uncover the invisible systems that keep you alive. Because the more you understand your body, the more extraordinary it becomes.